Hi there, welcome to Caltex Academy. Today on our board we have some chemistry questions from balancing chemical equation. This is a center of chemistry. The moment you know how to balance equations very well, then chemistry may not be intimidating to you. And today I've decided to simplify for you how to balance chemical equations without problem. So in our number one question, which is on the board here, is all about conversion equations. So we have some hydrocarbons here. The first one is propane. When it burns in oxygens, it gives out carbon dioxide plus water. So how do you balance all chemical equations? And to balance chemical equation is not all that difficult. The first thing we have to do is to know that there are two sides from the chemical equation. A chemical equation have two sides. We have reactant side. So the whole of this side here is the reactant side. And then this side here is referred to as the product side. Meaning if two chemicals react together, they produce certain product, and that is why the right hand side of this chemical equation is referred to as product side. So with all this said, we can now move on and see how we can tackle all this. The reactant side is referred to as left hand side. So what we have to do is we balance the equation in terms of number of atoms of each of those elements. So let's have the left hand side, which is the product side, and we also have right hand side, which is referred to as the product side. And we identify all the elements from the left hand side here, and the first one here is carbon. So we have carbon. The second one is hydrogen. Here we have our hydrogen, and the third one is oxygen. So let's also go to the right hand side, which is the product side, and we also identify our elements here. So we first also have carbon, and we move on to oxygen, but because we have started here with the hydrogen, let's have them corresponding. So let's also bring hydrogen here, and we go on to oxygen here. Now let's look at the total number of atoms in each of these cases. So from the left hand side, there are 3 atoms of carbon here. On this side, we have 1 atom of carbon. From the reactant side, we also have 8 atoms of hydrogen. And from this side, let's check, we have 2 atoms of hydrogen from the right hand side. And also from the left hand side, oxygen, we had 2. From this side, we have oxygen 2 plus 1, there are 3. So how do you make sure that they are balanced? As I mentioned earlier on, I said balancing chemical equations depends on the number of atoms of each of the elements from the equation. The moment they are all the same, then we say that chemical equation is balanced. So let's start balancing with carbon here. So since we have here 3 from the left hand side, and in this right hand side we had 1, meaning for us to obtain 3, we need to multiply the number of atoms from the right hand side with also 3. So 3 times 1 is 3. So here we can place 3 before carbon dioxide, and this carbon dioxide will alter the number of atoms of oxygen. So before we move here, let us see that carbon is already balanced, and the number of oxygen from the right hand side has increased to 3 times 2, making 6 plus 1, now 7. So this one has gone to 7 instead of 3. So let's take a look at hydrogen. So we have 8 atoms of hydrogen from the left hand side, and here we said we have only 2. And for us to obtain 8 atoms of hydrogen to the right hand side, we need to multiply this by 4. Such that 2 times 4 making 8 exactly like what we had here. So if we have 8, we multiply it by 4, meaning we have to bring this 4 and place it here. And the name given to this number, I've just written 3 and 4, is referred to as molecules. So there are 4 molecules of water containing 8 atoms of hydrogen and 4 atoms of oxygen. At this side here, we have 3 molecules of carbon dioxide gas containing 3 atoms of carbon and 6 atoms of oxygen. So after balancing these 2, hydrogen and carbon, let us check on oxygen to see whether it is balanced. So here, as we mentioned earlier on, we had 6 atoms of oxygen, and here by placing our 4 in front of water, the number of atoms of oxygen from the water has been altered to 4. Because we have 4 times silent 1, here we have 4. So 4 plus 6, the total number of oxygen from the right hand side has increased to 10. But this side here is only having 2. So for us to get 10 from the reactant side, we need to multiply 2 by 5 to obtain 10. So let's place 5 before oxygen, such that if we multiply 2 times 5, we obtain 10. So from here, our first equation is balanced. But we have to make sure that exactly all these atoms are the same. So let's try to erase what we had here, and we now get the new number of atoms of each of those elements from right hand side and left hand side. From here, carbon, we have 3 atoms. On the other side, 3 times 1, here 3. So let's move to hydrogen. Hydrogen, we have here 8, and this is the only one, so we have here 8. Now let's go to the right hand side. We don't have hydrogen here, so we have only hydrogen attached to water. So 4 times 2, that is 8. And you can see the hydrogen atoms are balanced also. Let's move to oxygen. We don't have any oxygen around here, but we have here. So 5 times 2 is 10. And from this side, oxygen has been scattered to carbon, dioxide gas, and water. So here we have 3 times 2, making 6. So 6 plus, on this side we have 4 times 1, that is 4. 6 plus 4 is 10. So we have also 10 as the number of atoms of oxygen on either side. So our equation 1 is balanced. And this is how simple to balance chemical equation. Again, number 2 is a comparison equation of this hydrocarbon referred to as butane, and whether this can be written in its structural form like this. Like if I'm to write the structural form, here we have 3 carbon atoms that are chained with this covalent bond like that, and then we have 8 atoms of hydrogen everywhere here attached to this carbon with this covalent bond, and that is the structure for the first one referred to as propane. So this is the structure of propane. Now for butane, we just need to add another extra C to make 4, and we distribute the other 2 remaining 1 to make also the same structure. For now, we are not after the structure, but we are after balancing chemical equation. So let's move on to the second question here, and we also do the same, where we have the left hand side and we have the right hand side. So again, we have carbon, we have hydrogen, and we have oxygen from the left hand side. From the right hand side, we have the same element, carbon, hydrogen, and oxygen. So let's check on the number of atoms of each of these. So for carbon, from the left hand side, we had 4. From here, we had 1. And from the left hand side, the number of hydrogen at 10, and from this side, so for hydrogen here, there are only 2, and the number of oxygen from the left hand side are only 2, and the number of oxygen atom from the right hand side are 3. So let's move on and see how to balance, starting with carbon, and we look at carbon from the right hand side. Since we have 4 here, we needed a molecule of 4 to be placed in front of our carbon dioxide, such that 4 times the silent 1 somewhere here, we get also 4. And then we can go on to say that, okay, if I multiply this by 4, I will get 4 to balance up that. Now, by placing this 4 here, it has created a problem to oxygen, but let us first ignore oxygen. Let's go to hydrogen. So hydrogen, we have 10 from the left hand side, and from the right hand side, we only have 2 atoms of hydrogen. So to make 10, we need 5. To multiply 2 to make that 10. So we multiply 2 by 5, making 10. So placing our 5 as a molecule in front of water will balance hydrogen. Now, placing 5 and 4 into water and carbon dioxide gas respectively has created a problem to the number of atoms of oxygen from the product side. So let's identify the new number of atoms of oxygen from the product side by multiplying 4 by 2, making 8. And from this side, 5 times 1, making 5. And if we add these 5 and 8, we get 13. So from the right hand side, we have 13, but the left hand side, we have oxygen only 2. So how do we get 13 here? So to get 13, we need a fraction. We have to get a fraction of 13 over 2. You know in maths that if you have a number like 13 over 2 times 2, the 2 will cancel and obtain this 13 here. But of course, we're not going to cancel them, so we'll have this a fractional molecules. But in real life, we don't have the number of moles that is fraction in form. So for us to eliminate this, we have to multiply the whole of this equation by 2, so that we eliminate this fraction from this side here. Now, if we multiply this by 2, we'll have a new molecule 2 in front of this hydrocarbon, and when you multiply this by 2, then the denominator will have to go, and if you multiply this one by 2, we'll also get a new number. 4 times 2, we get 8. So we have 8 molecules of carbon dioxide gas. Now, when you multiply 2 by 5, also we have to change this number to 10. So we have 10 molecules of water. So let's go back and see that our equation is balanced by looking at it once more here. So let's start with our carbon. So for carbon, we have 2 times 4, that is 8 from the left hand side. And then here 8 times 1 is also 8. That is good news. Let's move to hydrogen. 2 times 10, we have 20, and that is the only hydrogen here. So we have 20 atoms of hydrogen. Now let's move to the right hand side and where hydrogen is. So we have 10 times 2, that is 20. And we can see that they are rhyming. The first 2 elements are okay. Let's move to oxygen from the product side. Oxygen is only good from here. So we have 13 times 2, that is 26. So here oxygen is scattered in the 2 compounds of carbon dioxide gas and hydrogen and water. So 8 times 2, that is 16. So we have here 10 times 1, that is 10. So 10 plus 16, we have 26. And as you can see, voila, all these equations are balanced properly. So if you're excited to get more important content just like this, subscribe to the channel and you'll get a lot of this kind of videos. Before you pen off, I have some small exercise for you here. You can try and share your answer in the comment section. So if I have something very simple, just like this one here, you can guess already the name of this compound. This is called methane because the carbon atom is 1. So if methane is burned in oxygen, it will also produce carbon dioxide gas plus water. Now go ahead and make sure that you balance this equation and you share your results in the comment section. See you in the next one, where we shall look at also balancing equations of reactions between bases and acids. If you're excited, we'll see ourselves in that video. Peace out.